Welcome dear children. Today we are continuing with practice at 1.2 and today's lecture we are going to understand sum number 2 to 6. Since the sums are quite simple and comparatively small, so I have included sum number 2 to 6 in one video. Now let's take the next sum, that is practice set 1.2 second main sum. In triangle PQR, PM is 15. The entire thing from year to year is 25. PR, the entire thing from top to bottom, is 20. NR is 8. We have to find whether line NM is parallel to side RQ. So in order to find that they are parallel, first we have to check their proportion. So in order to check the proportion, that is PN upon NR, we have to check if Pn upon Nr is equal to Pm upon Mq. So certain values are not available, like Mq is not there and Np is not there. So first we will find that. So here M is between P and Q. So you have a triangle P Q R and you have this point M here and N here. Value of this is 15. This value we don't know. NQ is 8. This value we don't know, but the entire thing we know from year to year is 20 and P to Q is 25. Now M is between P and Q. That means what? PM plus MQ. When we add these two values, we will get the value of PQ, right? So when we total this PM to MQ, we will get the entire value, which is PQ. So what is the value of PM? PM is 15. MQ we don't know, so we will write MQ as it is. And what is the value of PQ? PQ is 25. PQ is 25 here as well as the entire thing. Okay. MQ. So 25 minus 15. When you bring 15 this side, it will become minus. Therefore, MQ will be equal to 25 minus 15, which is 10. Now, the other side. RN, PN plus NR is equal to PR. Why? Because N is between R and P. How much is PM? PN. PN is, we don't know, so we write PN as it is. NR is 8 and PR is 20. So PN is equal to 20 minus 8. When we bring 8 this side, it will become 20 minus 8, which is 12. So we have got the values. Okay, we have got the values of PN, which is 12, and we have got the value of MQ, which is 10. Okay, now using the basic proportionality theorem, we will find whether the lines are parallel. So what is the values we have to check? So we'll check the ratio. Which ratios we'll check? Pn upon Nr we have to check, and the other side we have to check Pm upon Mq. How much is Pn? Pn is 12, Nr is 8, 4 2s are 8, 4 3s are 12, and Pm is 15, MQ is 10. Okay, so the first ratio we got 3 upon 2. The second ratio, pi 3s are 15, pi 2s are 10. So this also we got 3 upon 2. So we have got that Pm upon MQ, that is Pm is to MQ, is equal to Pn is to Nr, which is, how much is the ratio? 3:2. Since the sides are in proportional, therefore side line NM is parallel to side RQ. So let's see, your N is between P and R, therefore Pn plus Nr is equal to PR. Pn plus Nr is 8 and PR is 20, therefore Pn is equal to 20 minus 8, which is 12. Okay, this side, we are doing this side. The entire thing, the total is 20. One part of it is 8. So what will be the smaller part? The smaller part will be the bigger part minus the smaller part. Okay, so we got Pn is 12. Then the right hand side, Pm plus Mq will give you this entire thing. So Pm is 15, Mq we don't know, and Pq is 25. Mq is equal to 25 minus 15, which is Mq is equal to 10. Now we have to find whether Nm is parallel to Rq using basic proportionality theorem. So in triangle PRQ, Pn is to Nr. Pn is to Nr. How much is it? Pn is 12. We have found Pn is 12. Nr is 8. So 12 upon 8, that is 4 2s are 8. 4 3s are 12. So the first equation we got 3 upon 2. The next one was Pn is to Mq, which is 15 is upon 10. So after cancellation we got 3 upon 2. So when we compare the first equation from the second equation, we find that both the values are equal. Therefore, by converse of basic proportionality theorem, line NM is parallel to side RQ. Now we take the third question, the third main question in triangle MNQ. NQ is a bisector of angle N. Okay, so which theorem? The previous sum we used the basic proportionality theorem. In this one, when angle bisector is coming, then we have to use angle bisector theorem. So the values are given. So what are the values given in triangle M N P? Mn is 5, NP or Pn is 7, and here you have the bisector, and we have Q here 2.5, and you have to find this part. That means you have to find PQ or QP. So using bisector theorem, since it's already said that QR is a bisector, so which sides will be in proportion according to angle bisector theorem? Mn upon Pn will be equal to Mq upon PQ, right? According to angle bisector theorem, the bisector of an angle of a triangle divides the side opposite. So this bisector divides the side opposite to the angle in the ratio of the remaining sides. So this ratio, that is MQ upon QP, will be equal to Mn upon Pn. So Mn upon Pn, let's write the values. Mn is 5, Pn is 7, MQ is 2.5, and PQ or QP, it means the same. You write PQ or QP, we'll write QP because it's given in the question QP. And now we'll cross multiply. So what we'll have? QP into 5 is equal to 7 into 2.5. Therefore, QP is equal to 7 into 2.5 upon 5. Now, since there's a decimal on top, I will multiply both by 10. Whenever you multiply the numerator, in order to remove the decimal, we have to multiply the denominator also. So, what do we get? 7 into 25 upon 5 into 10. 5 ones are 5, 5 5s are 25, 5 ones are 5, 5 2s are 10. So now we have got 7 upon 2. Now we have to divide 7 by 2. 2 3s are 6, 1, decimal 0, 2 5s are 10. So what is the value of QP? After cancellation and solving, we get the value of QP as 3.5. So let the neat solution in triangle MNP. NQ is the bisector. NQ is the bisector of angle N. MN is 5. PN is 7. MQ is 2.5. And then find QP. Ray NQ bisects. Ray NQ, this one, bisects the angle M and P. M and P. Therefore, by the property of angle bisector of a triangle, which sides will be in proportion? The sides which will be in proportion will be Mn is to Np will be equal to Mq is to Qp. Now we are substituting the value of Mn. Mn is 5. It's given in the question. Np is 7 or Pn is 7. Okay. Mq is 2.5 and Qp we don't know. After cross multiplying, we get the value of Qp as 3.5. Now we go to the next question, practice set 1.2, the fourth sum. In this, the measurements are given. We have to prove that AP is to PB is equal to AQ is to QC. Now whenever you see parallel lines, remember which theorem will we use? We will use a basic proportionality theorem. So which sides are, which measurements are given? Angle APQ is equal to angle ABC, which is equal to 60. Now why are they congruent? Because they are corresponding angles. So by corresponding angle test, corresponding angle theorem, okay, they are congruent. So when the angles are congruent, automatically the lines will be parallel. Which lines will be parallel? PQ will be parallel to BC. Okay, now we have got the parallel thing. So therefore, which sides will be in proportion? When the lines are parallel, then the bisector, the sides which will be in proportion will be AP is to PB, which will be equal to AQ is to QC. So we have proved. Simple. Okay. Now let's write the proper solution. Angle APQ is equal to angle ABC, which is given in the figure, which is 60 degree. Since they are equal, they are congruent, right? APQ is congruent to ABC. So therefore sec PQ is parallel. Sec PQ is parallel to sec BC. Why they are parallel? Because the corresponding angles are congruent. Therefore, by corresponding angle test for parallel lines, sec PQ is parallel to sec BC. Now in triangle ABC, we have got that sec PQ is parallel to side BC. Therefore, by basic proportionality theorem, which sides are in proportion, AP is to PB is equal to AQ is to QC. So we have proved the question. What is the question? Prove that AP is to PB is equal to AQ is to QC. Now we go to the fifth question. This is a trapezium. Now what is a trapezium? The trapezium has opposite sides parallel. And here it's given AB is parallel to side PQ. It's given. And PQ, and it's also parallel to DC. So these three sides AB, PQ and DC are parallel. So which theorem will we use? Parallel lines and they are transversal. Three parallel lines and they are transversal. Okay. So what are the values given? The values given is AP is 15, PD is 12, BQ we don't know, and QC is 14. QC is 14. So according to parallel line, according to the property of three parallel lines, which sides will be in proportion? AP upon PD is equal to BQ upon QC. Now what is the property of three parallel lines? When three parallel lines are intersected by a transversal. So which is a transversal? AD is a transversal. Okay, AD is a transversal and it is intersected by the parallel lines. Which are the parallel lines? So we can take the parallel lines are AB, PQ and DC, and it is intersected by a transversal. The ratio made will be equal. The intercepts, the ratio made will be equal to the ratio made by the intersection by the other transversal. So which is other transversal? BQ. BC is the other transversal. So we have written AP upon PD is equal to PQ upon QC because of the property of three parallel lines and their transversal. So what is the value of AP? AP value is 15. Here is 15. How much is PD? PD is 12. In the question PD is 12. In the diagram PD is 12. BQ we don't know. We'll write as it is BQ. QC is 14. Now we'll cross multiply. So BQ into 12 will be equal to 15 into 14. So BQ is equal to 15 into 14 upon 12. Cancellation, we can go in 3. 3 4s are 12. 3 5s are 15. 2 2s are 4. 2 7s are 14. Now we got 35 upon 2. Now we'll divide 35 by 2. See, even the division, the cancellations I am showing you all, so that you are very clear with the answer, how the answer we got it. Okay, so 35 divided by 2. If you don't want to see this part, you can just skip the part where I'm showing the calculation and you can calculate on your own. So 2 1s are 2. 1, bring down 5. 2 7s are 14. 1, decimal, 0. 2 5s are 10. So the answer is, what were we finding out? BQ is 17.5. So let's see clearly. So let trapezium side ABC, in trapezium ABCD, AB is parallel to PQ, parallel to DC. Value of AP is 15, PD is 12, QC is 14, and we have to find BQ. So ABCD is a trapezium, AP is 15, PD is 12, QC is 14. The sides are parallel, AB is parallel to PQ, parallel to DC. And since AD and BC are transversal, therefore by the property of three parallel lines and the transversal, we have AP is to PD is equal to BQ is to QC. Now we are substituting the value of AP, which is 15, PD which is 12, BQ we don't know, QC is 14. We cross multiply and we got BQ into 12, which is equal to 15 into 14. See, we are cross multiplying here. Then in order to have BQ alone, we'll bring 12 this side on the right hand side. That means it will come below. And after cancellation, we get 35 upon 2. And when we divide 35 by 2, we get 17.5. And therefore, the answer is BQ is 17.5. This question, the sixth question, what are the conditions? Find QP using the information given in the figure. So in the figure, they've just given the information. In the question, it is not there. So what is information given? MN is 25. NP is 40. MQ is 14. Which theorem will we use? You can see that NQ is the bisector of angle. NQ is a bisector of angle M and P. Okay. So these sides are in proportion. So which, according to angle bisector theorem, which sides will be in proportion? Mn is to NP will be equal to MQ is to QP. Mn is 25, NP is 40, MQ is 14, QP we don't know. We'll cross multiply and what do we get? QP into 25 is equal to 40 into 14. QP is equal to 40 into 14 upon 25. We will cancel by 5. 5 5s are 25. 5 8s are 40. Now we got 14. 8 into 14 upon 5. It's not getting cancelled. So we will multiply 14 into 8. 8 4s are 32. Carry 3. 8 1s are 8. 9 10 11. 112. Now we got 112 upon 5. So we have to divide 112 by 5. So 5 2s are 10. Bring down 1. 1 minus 0 1. 2. 5 2s are 10. 12 minus 10 2. Put a decimal here. 0. 5 4s are 20. So what is the answer we got? 22 upon 4. So QP is equal to 22 upon 4. So let's solve it here. In the question they have not given the details, only in the figure they have given the value of Mn is 25, the NP is 40, NP is 40 here, MQ is 14, ray NQ bisects angle MNP, ray NQ bisects angle MNP. Therefore, by the property of angle bisect of an angle, we have Mn is to NP, which will be equal to NQ is to QP. Then we'll substitute the values. Mn is 25, NP is 40, MQ is 14, PQ we don't know. After cross multiplying, we got PQ into 25 on one side, 14 into 40 on the right hand side. In order to bring 25 this side, we will bring it down here. Okay, because when you have multiplication, then when you bring it to the right hand side of the equal to side, then it will become divide. So after cancellation, we got 112 upon 5, and after dividing 112 by 5, we got the answer 22 upon 4. So value of PQ is equal to 22.4. In the next video, we'll understand sum number 7 of practice set 1.2. Thank you, dear children, and God bless you.